Alright, welcome. This is the IM1 Honors Final Review. This is the fourth part and the final part. This is going to be covering questions 16, 18, 19, 20, and 21, I believe. These are multiple, these 16 through 18, these are multiple correct answers, so you're going to select all that applies. Alright, so the first 5 terms of the sequence are listed below. 4, 8, 16, 32, 64. Wow, it's going up dramatically fast. I think it is geometric here, okay? They say Alright, sorry about that. They say which of the following functions, either explicit or recursive, correctly describe the nth term of the sequence. Alright, select 2 that apply. Okay, so yes, it is a geometric sequence because from 4 to 8 you multiply by 2, from 8 to 6 you multiply by 2, from 16 to 32 you're multiplying by 2, and 32 to 64 you're multiplying by 2. You can't, this is not arithmetic. You cannot go up adding something. From 4 to 8 you add 4, from 8 to 16 you add 8, from 16 to 32 you're adding 32, 16, from 32 to 64 you're adding 32. So do you see, you cannot add, you have to multiply. So you would say the common difference here, it is 2. Common ratio. The common ratio is 2, that's why I would say this is geometric. Alright, so the first term is 4 because you do start at 4. Alright, here is the explicit using the first term. It is f of 1 r to the x minus 1. If you're using the 0 term, it would look like this. Right? But again, I have the first term, so it's going to look like this. Alright, so plug it in. 4 is the first term, and 2 is the common ratio. So your answer looks like it can be this one. Okay? Then, this one, we would have to look for its recursive form. This is what the recursive form looks like. So plugging it in, it is the common ratio goes here. So it looks like it is this one. Right? So it would be both C and D as valid answers. Right? One is the explicit and one is the recursive. Make sure you understand the format of the formulas for the test. Okay? Both recursive and explicit. Alright, let's look at 17 here. Alright, 17. A sequence is defined by the recursive by the following. F of 1 equals to 5. F of n equals to 3. Times f of n minus 1 minus 2. Which of the following statement is true? Select 2 that applies. Here we go. Alright, so again, I'm just going to find the terms by filling in the chart. I know the first one is 5. How do I get to the second one? I plug it in. So look, this says 3 times f of n is your previous term, so this is going to be 5. Then I'm going to minus 2. Okay, this is what it says. Alright, this 15 minus 2 is just 13. Again, now I repeat the same process. Okay, 3 times 13 minus 2. Okay, this is your previous term. Remember, this is referred to your previous term. Right? So if you do that, it should look like this. 1 is 5, 2 is 13, 3 is 37, 4 is 109, 5 is this, 6 is this, and 7 is this. Select all that, select 2 that apply. I think there's only 2 answers here. 2 is 13. Yep, that is a valid answer. 3 is 37. Nope. 4 is 109. Nope. 5 is 320. Yep. There you go. 5 is 325. And that's it. All the rest are not valid. Right? Okay. Alright. Good. Again, make sure you fill in the chart to make your life easy for number 17. Alright, let's look at number 18. Which of the following situation can be modeled by a linear function? Select all that applies. Right? Make sure you look for a constant rate here. Linear functions are all have a constant rate. No percentages, okay? First one, a cop car chases a robber at 80 miles per hour. 80 miles per hour, that is a constant rate. So that is valid. B. Mr. Lopez invests $1,000 into a saving account that grows at a rate of 3% per year. Do you see the percent here? Bad. Nope, not linear. C. A tree was 12 feet tall when planted. It grows at a rate of 6 inches per year. The word per, there's no percentage, so we would say that is a constant rate. So C is a valid answer. D. Nathan throws a paper airplane in class. It falls at a rate of 9.8 meters per second squared. Again, 9 meters per second, even though they say squared, it is still a constant rate. It's always 9.8, does not change. That is the force of gravity. E. The amount of players in Fortnite game decreases at a rate of 12% every 7 minutes. The percent indicates that it is not a linear function. It is a percentage, right? It depends on the amount of players. 12% of 100 is 12, but 12% of 20 is what, like 1 point something? So it depends on your amount. Percentages can, right? The decrease will change here. And last one, the cherry blossom petals falls at 5 centimeters per second. Again, 5 centimeters per second is not a percentage, it is linear. So the only linear ones you have here is A, C, D, and F. Right? Remember, you are looking at a constant rate, so no percentages, and you will be fine for a linear function. Alright, let's look at 19 here. There it is, 19. Alright, a pattern is shown. Assume the pattern will continue growing the same way. First one, beginning, you have 1. At the 1 minute, you have 4 more, right? And the second one, you have 16. Okay? How many triangles will be in the next sequence? It seems like it's multiplying 4 to each side, so I would say the common ratio is 4. Once I get a common ratio is 4, I extend it further. 16 times 4 is 64. 64 times 4 is 125. So at 3 minutes, it is 64 triangles, and at 4 minutes, it is 1,256 triangles. Let's look at the next one, part B. What is recursive rule for the sequence shown below? There is a common ratio, so it is geometric. So you have f of x equals r times the previous function. This is a geometric recursive equation. So f of x equals to 4. 4 is your common ratio. There you go. That would be how the recursive looks like. Next, and that's it. 20. A sequence here is shown below, negative 11, negative 5. 1, 7, and 13. Looks like it is growing very slowly, so I think it's arithmetic. So it says, write a recursive formula for this sequence. Explain how you determine your answer. There is a common difference, so there is an arithmetic. How do I do that? I just do the different tests. So it looks like I'm adding 6 to each term to get to the next one. Negative 11 plus 6 is negative 5. Plus 6 is 1. Plus 6 is 7. Right? So again, the common difference here is 7. So here is the original recursive formula. Plug 6 in for D, and that is what I got. Next, part B, write the recursive. Again, the explicit, right? Looks like this. That is the recursive for the arithmetic. Plug in the first term, which is negative 11. Common difference here is 6. Or you can write this in y equals mx plus b, but notice I'm using negative 17 because I have to find the zero term, the y-intercept term. This is the first term, so I'm using negative 17 here as the y-intercept. Okay? Alright, I think we're almost there. 21. Kaiser Football Club is selling food at a home football game. They make a profit of $12 for every package of hot dogs sold and $6 for every package of hamburgers sold. The Booster Club needs to make at least $160 per game, but can only carry a total of 21 total packages in the ice cooler. This is very important, right? Because there is a constraint by the ice cooler of how much they can carry. So again, step 1 is to always define the variables. In our case, let x represent the package of hot dogs and y represent the total package of hamburgers. Write a system of linear equations to fit the scenario. So x plus 4 is less than or equal to 24 because that is the package equation for the ice cooler. Again, it is less than or equal to 24. You cannot pack more than 24. Can only carry, right? Can only carry. That's the key word. All right. Next, they need to make at least a profit of $160. That is why this would be the profit equation. Okay. $12 times X plus $6 times Y has to be greater than or equal to $160. Alright, to graph it, you have to put it into Y equals MX display, or make your life easy, plug those two equations into decimals. That shaded region here would be your solution set, because again, it is a system of inequalities, okay? And it would be any of these would work. Remember, you can't really have negative values, so only look at the first region, but this would be all valid answers. Alright, so there you go. That is all your solutions for the final review.